We use a little bit of math in this course, and for some folks who haven't used math in a while, it's probably a good idea to do a little bit of review. So that's what I want to do in these few slides. For the most part, we work with straight line equations. We do a lot of just linear algebra with equations, say, of the form y equals mx plus b. There's an x in there, where x is something on a horizontal axis and y is something on a vertical axis. Just to give an example, let's look at the equation y equals 100 minus 2 times x. And let's just think a little bit about that equation. So, for example, what happens if y is equal to 0? Well, if y is equal to 0, then that means 100 minus 2x is equal to 0, because that equals y, which is now 0. And that also then means that 100 equals 2x, or that x equals 50. So that tells us that when y is equal to 0, x is equal to 50. These two go together. On the other hand, what about when x equals 0? Well then, y equals 100 minus 2 times 0, so y just equals 100. Now let's take that over to our kind of sloppily made diagram over here. When x is equal to 0, so here's 0, y is equal to 100. So let's say that's 100. When y is equal to 0, x is equal to 50. And the line itself is the straight line that connects those 2 points. What about the slope of the line? So remember what slope is. Slope is equal to rise over run. A couple ways we could think about this, and let's move over to the next slide to illustrate it. Quickly putting that picture back up. The rise of this, so it's going downhill, it's going down, so the rise is this vertical distance here, and it's going down, so it's minus 100, and the run is this horizontal distance, it's this 50, and that just equals minus 2. Now remember what the original equation was. It was y equals 100 minus 2 times x, so it's also useful to note that the slope, when we write it as whatever is on the vertical axis over here equals stuff, the slope of this linear equation is just this minus 2 right here. Okay, so that's a quick review of how straight line equations work, and that's a lot of what we do in this class. Let's try another application. Let's suppose that I give you 2 points. And then I want you to find the equation. So find the equation of the line that goes through them. There, I'll misspell through for the sake of fitting on the slide. So how might I do this? Well, one way to do this would be to take 2 points. One point is the point 2, 3, where this is now an ordered pair, where we have x and y. So one point is 2, 3, and the other point, let's say, is 6, 4, where again that's an x and that's a y. In a diagram, we have x on this axis, y on this axis. Let's just count out 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. So what are these 2 points? The first point, 2, 3, 2, 3, and there's that point. The other point, 6, 4, 3, 4, 5, 6, 4, this point here. I'll exaggerate my dots here, and I want to find the line, the straight line that goes through those dots. So how do we do that? Well, first, let's find the slope. So the slope's the rise over the run. We could do that a couple of ways. We could look at this triangle here that's defined this way, and the rise would be 1, and the run would be 4. So slope equals rise over run, and that equals, in this case, 1, and it's positively sloped, it's going up, so it's a plus 1 over 4. How else might we see that? Well, we could also just look at the 2 points and see that we're, the rise is the delta y, the change in y, the change in x. Change in y is just looking up at those 2 ordered pairs up there. It's 4 minus 3 divided by 6 minus 2, and that again equals 1/4. So this is part of the solution, but remember the question here was let's find the equation between these points. So far we've just found the slope, and it's 1/4. How do we go the rest of the distance on this? Well, let's do that. Turns out that we can find the answer by writing the following equation. Y minus y1 equals the slope, which we'll call m, times x minus x1. And we can put in any value of x1 and y1 that's on the line. For example, we could put in 2, 3. And so that means rewriting this as y minus 3 equals m times x minus, now for x1 we'll put in 2. One more thing we have to make note of, we've already found the slope m, it's 1/4, so we can rewrite this as y minus 3 equals 1/4 times x minus 2. Well, if we simplify this, we'll have the answer. I mean, this is in some sense the answer, but it's not quite pretty yet because it's got lots of terps floating around. So let's go ahead and simplify. This equals x over 4 minus 2 over 4, or 1 over 2. If I just want to get y alone over here, I end up with y equals x over 4. Now this is minus a half plus 3, so it's plus 2 and a half. And that's the answer. That's the equation, and we derived that from 2 points. What else do we do in this class? Well, we also tend to talk about slopes, and sometimes not just slopes of straight lines. And so let's talk a little bit about slopes. Let's illustrate that idea. Let's suppose we have the following function. P equals 10 minus Q. Now it turns out, as we'll discuss in the course, this can sometimes be the way a demand curve looks, such that P is the price and Q is the quantity, and then sometimes we're interested in revenue, which is equal to P times Q. Well, if we substitute in, that's 10 minus Q times Q, which, simplifying a little bit, gives us 10, or just multiplying it out rather, 10 times Q minus Q squared. So we could ask the question, how does revenue, this R thing, vary with Q? If we were to plot this thing out, we'd find out with Q on this axis and revenue here that it starts out like this, reaches a max, and comes back down. Now, we're often interested in the slope of such things. So for example, we might be interested in the slope at this particular point, call it Q0. Literally, what is the slope there? And the slope there is also the slope of a line that just touches, it's just tangent at that point. Now there are ways of finding that, and some of you know those things from other kinds of math classes, but let's just talk about the intuition of what's going on. Suppose we think about a couple of other quantities that surround Q0, and we'll call them Q1 and Q2. Q1 has associated with it some level of revenue that we'll call R1. Q2 has associated with it some level of revenue that we'll call R2. Now, the slope And I'm going to say the slope around, not quite at, but around Q0 is equal to what? Well, rise over run is, the rise is R2 minus R1. The run is Q2 minus Q1. That's not the slope at Q0, but it's the slope kind of nearby, because it's sort of the average slope between this point here and this point here. Now suppose we could get the Q2 and the Q1 really close together, so we're getting a really good approximation, then we'd have the slope at Q0. So it turns out the slope at Q0, if we have this rev equals 10Q minus Q squared, well, it has the following form. The change in revenue, or the change in Q, is going to be equal 10 minus 2 times Q. Now that's a little bit magic as far as we're concerned at this point. If you've had a lot of math, or even a moderate amount, you know this is the derivative, dRev dq. And you know we can find it by taking the derivative of 10Q, which is 10, minus the derivative of Q squared, which is 2Q. And so that all means that the derivative, or the slope of this function at Q0, is equal to 10 minus 2 times Q0. Now, why am I doing all this? In this class, you don't need to know calculus to find slopes. I'll always give you how to find them, or give you the actual slope in the problem. I just want you to understand what's going on when we talk about slopes. And it's inevitable that we have to use some of these functions that that aren't just straight lines. So finding slopes of non-straight lines requires something. And again, the something here will be me telling you the answer. But just understanding what it is that we're getting is kind of handy. And that's about it for math you need to know to do this course. Yeah, let's jump in.